So ArcGIS Online will be covered, which and then the rest of the course will be covered. The ArcGIS Server is Esri's tool set for building online web maps. We'll talk a lot about ArcGIS Server. It takes some of the functionality you know from ArcMap and makes it available on online maps, so users don't need to use ArcMap. Users can go with Internet Explorer, Chrome, Firefox, and consume a web map that you build in a browser, and that's done with ArcGIS Server. There's a bunch of APIs. We'll talk about that. An API is an application programming interface. The one that I think really has the most future is the JavaScript API, so we'll cover most of the course talking about the ESRI JavaScript API, and there's a lot of free tools and templates available for the JavaScript API that you could use to extend your knowledge beyond what we do in the course. I occasionally have to miss a class. We sometimes travel for work. I'm not aware right now of any such occurrence in June. Basically, the classes there's tonight and then the last night. The majority of the classes in June, and right now I don't have travel plans in June, which is good. I'll let you know, of course, beforehand, and then what I've done in the past is recorded the lecture on YouTube. So that's, in general, the things that we will cover in the course. The real focus is building up to this, though. ArcGIS Server JavaScript API really lets you build some cool web mapping applications that you can serve to the public. And now, because it's funny, we won't even need ArcGIS Server here. You can use other people's map services, which is great because it enables me to teach this to you without getting special permission from the university to install the software and so on. You can use other map services that someone else has already published. So that's kind of cool. A true mashup. And welcome to 2015. The times have really changed. The grading of the course is spread out. Oops, I didn't mean to do that. Across hands-on lab work. It's similar to 555 for those of you that are in that. There's no there are quizzes that are take-home, similar to the quizzes that you took home in 555, and then most of the work is the 5 labs. Just like the other course, if you try hard and submit your work, you'll get an A. I mean, it's not hard to do well in the course from that aspect. One thing that's different, we won't be together very long. July 1st will be here before you know it, and we're done. I don't think there's time to do a final project. In 555, when we have a whole semester, I usually have you do labs and then a final project. I don't think we have time for that in such a constricted time frame. So I only have 5 labs on the docket for you and no final. However, and this would be easiest for those of you if you might have pre-existing. Sometimes people that take the course have pre-existing skill sets in web development or web programming. If you'd like to do a final project instead of the labs, you're welcome to. I mean, that might be harder for someone that's newer to the topics, and I'm in no ways suggesting you do that, but last year we had one student that was already knowledgeable in JavaScript, and he did a final project and didn't have to do the labs. For most people, the obligation is just do the 5 labs and get your 60%, and that's fine. But if you are interested in, we almost had a student, he's not able to join us, that wanted to do a project in coordination with his work, so he would have been a good candidate for something like that. So I throw that out there if you're interested. If you'd rather just do the 5 labs, that's perfectly fine. So there's no, unless you want to take that second option, there's no final project. There's just not enough time. I mean, really, it's the second half of June before we really get into things, and then we're done. There's challenges with doing this. There's good things. I mean, you're in and out and you learn the topic quickly. That's the challenge, though, is that there's not a lot of time to spread out. Like 555, there should be class, and it's hard. We're giving out our Mondays and Wednesdays for a month, so to help you out with that, I'll try as much as possible to give you class time. I mean, this doesn't list class time in the agenda, but I'll figure out a way to make time, whether it's splitting up and having a night have be half lecture, half class work time, or an entire night that's work time. We'll figure out a way to let you work on assignments during the class time, given that we're already here 2 nights a week for the month. But I'll know more about when that might be as time goes on. It's always difficult to predict exactly how fast things move. Every class is a little different. Sometimes with a small class like this one, things can move pretty quickly. So I'm pretty certain that we'll have time built in here for you to work on your lab assignments during class. So you don't have to come back and do it on another night. The best way to contact me is my work address, gconiglio@ene.com. I did have some issues last semester with my UB email, which have been resolved, but my iPhone is tied to that email address, so if you send me an email to that, I'll see it immediately, even if I am traveling. So that's the best way to contact me. And like I said, if I do have to cancel or postpone, I'll let you know as soon as possible. Right now, I'm not thinking that'll be necessary. I just jinx myself. I'm traveling a lot lately, so a little bit of a break would be nice. So that's the explanation of the course. Both the course, grading, content, and what specifically we'll be learning. Actually, minor changes 10.2, let's notice there's really no difference in the description. I think after, for what it's worth, the lab will be 10.3 in the fall semester, but I mean, not a whole lot of difference there either. Are there any questions? And we'll dig in. So we'll start out talking for a little bit about, how we got to the web that we know today. History of the World Wide Web. It's sad how much of this history I remember. Not this part. I'm not that old. A lot of the internet actually was around since the 1960s in the Cold War. The U.S. Department of Defense had a program called ARPA. It was originally a research project that was security-based. They tried to connect computers spread out across the world, or mostly across the United States, where that was a very different time. Everyone was concerned about a nuclear war, and the massive, among a lot of other bad things that would mean, the massive loss of information. So the U.S. Department of Defense designed a prototype network where computers spread across the country could share information in the event of a nuclear war where a lot of information is lost. And that really is the foundation where the internet got started. In 1969, the universities listed successfully connected their computers, and they're all in California and Utah. But that didn't grow that fast. Even by 1975, there were 57 research institutions, universities, and agencies. It's kind of funny, there's probably 57 machines in this lab connected to the internet if you think about it. By 1989, that was my first year at UB, there were still 100,000 computers. That's a lot more than 57, but that's minuscule compared to nowadays. UB was connected to the internet. I remember another student, I'd never heard of it until another student told me about this lab up on the spine where the computers were connected to other computers at other universities. That just blew my mind. It's like, you're kidding. I'd never heard of such a thing, and I'll never forget that I went and sent an email to a friend of mine at a different university. It seems so funny because we so take that for granted, but that was such a huge deal that I sent an electronic message to a friend of mine at another university, and then he answers right away. That was a big deal. Now, not so much. That was 1989 when I discovered the internet, but even then there weren't that many online. And it was certainly a novel thing. If my friend hadn't told me about it, I'm not sure when I would have. It was not public knowledge or something that the average person was aware of. The internet really came into prominence in the 1990s. It was much more complex. These people's emails had like 40 characters in them and delivered much less content. Early uses for the internet were for email. I basically for years just used it for email. and they were monochrome VAX terminals. I almost said the ones out there, but those have been gone for 15 years. Where they were just black screens with green lettering. Usenet was a protocol where you would provide news. That's the foundation of today's, user groups or news groups. File transfer really hasn't changed. People can share files that way. And Telnet, you could actually connect to a computer, kind of like today's remote desktop. So it was very basic, very, very basic compared to what we know now, and which has just exploded. In 1990, Tim Berners-Lee, and this is just that. The quiz might have a question or two. The quiz is take home if I didn't mention that. For those that weren't in 555, there might be a question or two on this, but the answer is right here. Tim Lee came up with a new way to share content with users, and he came up with HTML. Everybody knows HTML now. Hypertext Markup Language delivers multimedia content, and I could pick a billion sites to demo that. I'm not exaggerating. I probably could pick a billion sites if I was connected to the internet. I'm not one of the 100,000 machines. And we'll get to this more, but obviously everyone's familiar with the internet, probably, right? And HTML. Obviously there's a lot of different content displayed on this page, and that's basically, though there's more newer ways to do this, basically this content is delivered to us via HTML, and we'll spend, either later tonight and even maybe next Monday talking about that, and we'll learn basic coding. We could spend a whole course on HTML. We won't. We'll give you enough content on enough HTML guidance to get into the GIS part. But behind every website there is HTML text that defines how the page will work. And in 1990, this is what they invented, and that's when the internet started to take off. And that also introduced the concept of a web browser. A web browser is an application that knows how to interpret HTML. Microsoft Internet Explorer, Chrome, Netscape. Anyone? Anyone know what that word means? Netscape.
You said Netscape?
Netscape.
Oh, I remember it was a browser that I used in like high school. Netscape?
Yep. No, you're right. That is. That was the first browser. It's very sad that people don't even, other than you, don't know what that is anymore. Netscape was a strong competitor to Internet Explorer in various forms. Has been around since the beginning. Netscape was an early strong competitor to Internet Explorer that fell by the wayside. It sort of became Firefox. Some of the pieces of Netscape got picked up, and it's now Mozilla Firefox. And then what we'll talk about also is you need a way, if there's going to be 10 billion websites, you need a way to uniquely identify everyone. And they also came up with the Uniform Resource Locator. People are probably from URL. And what that means, in other words, is that every website in the world has a unique address. So if I put in CNN.com, my browser knows there's no ambiguity. The browser knows what site to go to. It may not come up with the same site everywhere. There's something called localization that we'll talk about at some point, where if I brought up, it came up with the United States edition. If I travel to Europe and put in CNN.com, it will come up with CNN's European-centered page. I've done that. It might even come up with a different page if you go to China or Japan or somewhere and try that. That's called localization, and we'll talk about that a little bit as well. This, I remember. The Xerox PARC Map Viewer was the first interactive web mapping application in 1993. Users could perform hyperlinks to perform very simple map functions like zooming in, panning, turning on layers, and so on. So to zoom in, literally you had to click these hyperlinks. See, zoom in times 2 times 5 and so on. Change display. It seems crazy, but this was a big deal. Just the fact that you could do this much in 1993. And I do remember using this for work. And it was developed by poor Xerox in Rochester. Has a lot of ideas still. They were the first ones that came up with Windows. I think Apple stole their idea. And I've heard the story. I know it's true that Apple people, I don't know if Steve Jobs, were touring Xerox in Rochester. Xerox had internally developed these computers where you could move them with a mouse, and they asked them about it. So, that's not going to go anywhere. And then Apple went back and developed the Macintosh. Hopefully, you know what a Macintosh is. Good. There were Macintoshes out there too. Other early examples in 1994. Canada was an early adopter with the National Atlas of Canada. Alexandria Digital, I got this from a web book. I don't remember that one. I do remember this, the U.S. Census Tiger Mapping Service. You could not only zoom in, this was United States space, it wasn't worldwide. I think they did actually have some worldwide layers. You could zoom in and get tiger census data and see, streams, roads, and things that people develop. A graduate of this department was instrumental in developing the first tiger web mapping service. His name was Brandon Flew. We were co-jail. I don't know if they still have a jail assistant funded. I hope they do. I was that, and then he was the year before, so we were in the office over there. It's now an air conditioner. And he went on to some pretty cool things. He developed the first tiger mapping service that you see here. We used to have to do a jail seminar every month. I don't know if they still do that, where we would talk about Adobe Photoshop or something, and no one ever cared. No one ever came. We would do all this preparation, and you might get one person that felt sorry for you and come. But I remember the one week in 1994, ready to come out, she said, "I'll do one on this internet." And he was sitting right here, and 67 people showed up. Everyone knew. I remember, okay, this internet is going to be a pretty big deal. Yeah, you knew. Okay, this is big. No one quite knew about it, and this whole room was full. Where normally you get 1 or 0 people, this whole room was full of people watching to see what he was going to show. I think that was in the fall of '94 when he did that, I think. Some additional, I think this has actually come back. The first, have you noticed up until now it was either government or research, university based. Around that same time, the private companies started getting the hint of, hey, maybe we can make some money off this. So you started to see more and more of a private presence. The first interactive web map that really took off, that led to now what we know as Google Maps and Bing and so on, was MapQuest. MapQuest was the first publicly available site that people knew about, where you could search for a business location, put in an address, and have a geocode. I think MapQuest is actually, nobody uses it. It's still out there. But obviously Google has kind of cornered that market. There's a new MapQuest. But that was a big deal. Just the ability to put in an address. Now we take it for granted. We can even do it on our phones. That wasn't that long ago. Maybe it was 1996. So right around, if you look at all of the things I've talked about, the web was delivery of content. I mean, by 1996 there was even a CNN, there was a Microsoft web page, even radio stations and newspapers started having web pages, but it was oriented towards delivering content to the public. We're going to put some information on a website and you can go read the information. Around the turn of the century, I hate calling it that, to me the turn of the century still is 1900. But the next turn of the century, around 2000, that shows how old I am. the internet started to change, and people realized that the internet would be more for sharing of content. And right around the turn of the century, people started calling for a new web that they called Web 2.0. And in general, Web 2.0 represented more like read-write functionality if it were a database. Or rather than just presenting information for users, the public could collectively contribute to websites, contribute their own content, their own information. And that led to collective intelligence. Right around the same time, maybe just before this, was the e-commerce. That caused the bubble to burst. So many people invested in e-commerce because it looked so attractive that it all crashed right around 2000. There were some crazy times where things made no sense. Amazon was worth more than Sears, even though Sears had physical stores and they'd been there for 100 years. Amazon had never even turned a profit, but everyone's investing in Amazon. Priceline, the airline site, this is the craziest one. That's still around, where you can buy airline tickets. Because of the stocks going up and up, Priceline had more stock value than all of the 5 major U.S. airlines combined, which is kind of crazy because without the airlines there'd be no Priceline. So it was kind of crazy, and I kind of wish I had invested money, and a lot of people do, and backed out of it. A lot of people did invest and didn't back out of it. But so you had e-commerce, you had all these they had everything, eBay, and you had Amazon and stuff. But it started moving more towards a collective intelligence, was a term that I found in one of the web books, where instead of just going to Amazon to buy something, Amazon has a very robust rating system where you don't just buy it, but then you go back and you rate what you bought. eBay, and more of this, there's no eBay warehouse. People, and you know what eBay is, people collectively buy and sell and rate things. Wikipedia, where people collectively contribute content. This was Web 2.0. And more recently than 2004, we've seen a lot of software as a service. Web applications and data are actually hosted online, and here's our first buzzword, in the cloud, which basically means that there's a server with your data and application, not where you reside. ArcGIS Online that I was talking about is software as a service. Now you have another option. So some of these things are only just coming into prominence in the last 5 years. Computer speed and processing and internet connection speeds have increased to allow this. Even if people imagined some of this years ago, the hardware wasn't there. I remember in the late 90s people talked about this and they wanted to set up GIS. Jack Danger was talking about it, the GIS clouds where people could consume their Microsoft cloud where you could just use Excel online. The computers and the internet weren't fast enough. The idea was ahead of its time. Now they are. So ArcGIS Online is an example of software as a service. Now you have two options. You can buy ArcGIS Desktop, ArcMap, buy a nice computer like this, download the data and work with it. Or you can host your data in a cloud, such as ESRI's cloud, and work with it online with something like ArcGIS Online. And then finally, as we get, this makes me happy, we were doing JavaScript in the 1990s, and people got away from JavaScript to complex, cool things like Adobe Flash, Microsoft Silverlight. We're headed back to JavaScript because it's lightweight, and we'll talk about some of these things probably next week. JavaScript is lightweight. It doesn't have a large footprint. It's relatively easy to learn. Those of you, I'm interested in your feedback. It's very similar to C#. So those people that were in 555 have an advantage. I think it's easier than C#. So those that were in 555, you got the harder version out of the way. But back to lightweight code. I mean, 20 years ago when we were back here, we were doing JavaScript already, and now it's coming back. One of the reasons it's coming back is that it's device independent. And that ties into this next bullet. You're not using a computer anymore. People are using phones and tablets. A lot of these other new fancy things like Silverlight and Flash don't work on these things. JavaScript works on everything. So that's another reason why JavaScript is coming back, and it makes me happy. And as I said, Web 2.0 is associated with the next generation of web technology that's more comprehensive. And we have things that are mind-boggling to me in the very large amount of detailed information, spatial information or otherwise that's shared. Big data. There's other classes about that. So sites like Bing that store oblique aerial imagery for a fair amount of the whole world, or Google Street View, where you have they photographed almost every street in the world, anywhere that's blue, like most of South America, Europe, and the United States, and now growing in India and a fair amount of Asia. So I can, oops. And go there and see exactly what this intersection looks like. This is amazing to me. I wouldn't want to be the person who has to manage the amount of data that this is. And there we're right there. But beyond just displaying of maps, the map and Street View data corresponds with to you put in an address and see what business is there and get reviews. So we see, okay, put in 550 Dick Road and see what restaurant is there. And while we're here, get user reviews of the restaurant. Is this the restaurant you want to visit or not? And then get directions to it. What else is nearby that restaurant? Link to their webpage and so on. So it's really has become a collaborative effort. This isn't just, this looks like a fun toy to look up restaurants, but this has changed so much even in traditional GIS usage. The Erie County Water Authority, I've been working with them for 20 years. They, at one point, wanted to develop a very expensive, they have valves that, valves aren't very tall. There's a valve box and a screw to unscrew the water valves to access water mains. They're about this high. So all winter they're gone. They're buried in snow. We talked about a massive effort to go and measure every valve to the inch, like it's 5 inches or 50 inches from the edge of the road, 60 inches from this pole, and make a GIS layer of these lines with the numbers on it. That would have taken, for the amount of valves that they had, that would have taken a decade. Now with Street View, they can see them. It's crazy. That whole decade-long project is out the door. They can open up Street View. Oh, there's the valve. So it's, well, this is a neat toy, and I like to play in Street View too. I like to look at parts of the world that I've never been to and imagine, going there someday. But it also has a lot of work applications as well. It's not just for fun. People can also contribute content through things like Panoramio, where people can upload photographs they've taken and geolocate their photographs on the map. So you can go to a part of the world that you've never been to. Like here, that spot near the spot in Bangkok where I clicked links to user-submitted photography. This isn't Google's photography, but the people in the general public that have taken pictures and uploaded the pictures to Google. You see there's quite a few. There really are quite a few. So we'll talk a little bit about crowdsourcing. This is an example of crowdsourcing where it's not a lot of the initial data is collected by Google, but this also represents data from the public. That's another thing just in the past 3 years or so where crowdsourcing has become so important. Any questions? Oh, I need to take this down. This was kind of a failure. But Google Web 3.0 is the integration of additional spatial collaborative information being taken to the next level with additional devices that you wouldn't traditionally expect to find content on, such as glasses. Google was developing, which I would never wear, but something tells me the next generation younger than me, maybe even younger than you, wouldn't have a problem with it. Where these glasses would let you be able to see a map, see information. They showed this person going to walk in the subway and a thing comes up saying the subway's closed. That would drive me crazy. And maybe it will drive Keo crazy, because since I made this slide, the project isn't suspended. They're retooling them, whatever that means. Sometimes that means they'll never to be returned. But even Apple has the Apple Watch. The devices are smaller and smaller. A company tried to sell us recently on this, for field workers to be able to note, people doing field studies just have the map right on their glasses and they just tap on their glasses to record something. They were very expensive and none of us could still fathom that. That just seemed like too much of a distraction. And their product was to be loaded on Google Glasses. They got real quiet too, and I asked, well, what are you going to do now that there's no Google Glass? And they didn't have a good answer to that, so we didn't buy their product. Web 2.0, some of this has not been around since 1999, but information gathering and collective intelligence, the trend towards web GIS being a collaborative effort. And the biggest example of this is this ArcGIS Online platform that I talked about. I need to get going on that. I will have the university send you an invitation, and you'll create an ArcGIS Online account through the class. I need to put in a ticket with UB to send them a list of emails. But just to show, and this even, at the time of this class, last time the only account I had was with UB. We were just getting started. Now, even at E&E, we've used like 50 projects. Even in the past one year. But the point, by bringing this up, the point that I wanted to make is how collaborative this is. So if I'm going to add a layer, I can search for something, and these are all map layers that someone has created and agreed to share with the general public. So you have federal user community created this, and these don't always work, layer of, at least in the United States, where there's currently weather watches and warnings. Either it's not working. That's the problem with collaborative. You don't know the accuracy of the data you're getting or how good their server is. Looks like I might not be able to see that. Oh no, there it is. So this is a collaborative layer that I just found on the internet of where there's currently weather warnings in the United States. Why? Well, that's interesting. There's some here. Let's see what that's all about. It's kind of windy. I wonder if those are wind warnings for boaters. Looks like it's out on the lakes only. And this is a roundabout way also showing some of the limitations of collaborative GIS, is that it can be slow. You don't necessarily always have the reliability as if you'd had the data right here. But just very quickly you can see how much GIS data is available. So it is 6 o'clock Wednesday. A special marine warning. A strong line of thunderstorms, really? It looked nice when I came in. Someone digitized, these are tornadoes that happened in Oklahoma, and someone digitized the tracks. Oh, look at that. Sometimes you don't know what's going on in the outside when we're in here. So we might lead to some nasty weather. So we saw with that example how ArcGIS Online is a collaborative effort. There's data both both presented by ESRI for the public's consumption, but a lot of data that the public has chosen to share with the world through this ArcGIS Online platform. A term that you'll use, you'll see, is a mashup. Here's an example. This is a site, and I got their permission to show this, a site we developed for Niagara County, New York, which is a web mapping site. This actually uses ArcGIS server that we talked about for the sheriff's office. Just like a TV show, they all get together at the start of a session or the start of a shift and talk about things going on in the county. So you see a bunch of different data here. We have imagery from ESRI. Those are air photos. It's kind of hard to see. Niagara County has a dispatch system that records where crimes occur. So when you call up the police and say a crime is occurring, it geocodes that to a dot. So the dots that you see are where crimes have occurred in the past 48 hours, I think. I don't remember what this was set to. So a mashup is bringing together data from a lot of different sources. There's a lot of different sources that are coming together to make this ArcGIS server site. You have air imagery from ESRI. You have shapefiles, GIS data of town outlines from Erie County. The geocoded locations of crimes, the yellow and blue dots, are retrieved from the sheriff's dispatch network. So when you call a dispatcher, call 911. Google Street View is available in this site. No Weather Service radar, so the splotches that you see doesn't turn out that good. The sheriff, they also wanted to have weather on it. So the National Weather Service has an RSS feed where I can actually put as a banner at the bottom of the page. It streams the current weather forecast. So there's weather. A lot of different things come to this one site that the sheriff's department uses to help manage and track where crimes are occurring. They have hot spots or hot zones where there's a rash of crimes. And then this also tells the officers at the start of their shift where to focus their attention that evening or that morning or whenever. So that makes it a true mashup in that it's gathering information from multiple sources. And this may be of interest because this is a Silverlight API, not JavaScript API, but this is the software that we'll learn in the second half of the course, ArcGIS server. And more. It happened 2 years ago. These are outselling computers. Computers, and I never thought, as a child of the 80s, I never thought I would see computer sales declining, but computer sales are going down because people are opting for tablets, phones, and so on. So developing a new application, often you have to consider that many people that use your application will be using it on a phone and not an actual computer. They are definitely, I should take that, they are definitely eclipsing the importance of desktop. And the nice thing about a phone is it can integrate current location. So when if you have geolocation turned on your phone and you take a photograph, the photograph is tagged with your current location. That can be good. We'll talk about crowdsourcing. During disasters, agencies use this information to gather information quickly from the public. The first disaster that I really started hearing about that was in Japan, the Sendai, the tsunami and earthquake in 2011. They lost access to a lot of municipal data because it was washed away. So they asked the public to take pictures and use Twitter in that case, and then the Twitter tweet would have the location and a photo. So the authorities in Japan were able to tag where things were happening. I think the Haiti earthquake, that might have been the year before that, was big for started to be big with geolocation or crowdsourcing during a disaster. It really helped during Hurricane Sandy, which was 2012, and it hit the New York City, New Jersey, Connecticut area, an area not used to receiving a hurricane of that strength. In talking to our emergency manager in Nair County, one of the counties, New York City, claims that they got extra millions of dollars. Their emergency managers were stuck. They couldn't get out to assess the storm damage because they were stuck in their driveways. So they asked the public, hey, tweet. They came up with a hashtag and a tweet. Can you tweet this to this hashtag? And so they gathered a lot of information for the public and were able to submit to FEMA earlier, before all the other counties, and their belief is that they got millions of dollars extra from the federal government because they were able to gather that data so early and easily using crowdsourcing through web GIS on mobile phones. And it's not always something that serious. You even have something like Guess Buddy. I have this on my phone. People, it's not quite a tsunami or a hurricane, but you can if you go to a gas station, you can enter and it'll geolocate what gas station you're at, the price that you paid. So people that are frugal can look at, I'm visiting Buffalo, here are the gas stations in Buffalo that have the cheapest price. So it's kind of a cool site. The reservations around this area usually have the cheapest gas, and then conversely there's the stations with the most expensive gas. So that's all crowdsourced data using geolocation on phones. It's something a little bit less serious than a hurricane, but it's all the same thing. Any questions so far? So that's kind of a background of how we got to where we are today. If I were to say, okay, what has changed the most since last year, it's ArcGIS Online and more use of online content that is easily developed and published without programming. I shouldn't be saying that in a programming class, but I don't think it doesn't eliminate the need for programming, because people will always want very complicated, detailed sites that won't be solved by ArcGIS Online. I would even argue that it could increase the demand for programmers by whetting people's appetite. You know, people publish these basic sites, so it gets more people introduced in GIS. At least this is my story. And because of that, down the road there could be more need for developers because more people are aware of GIS and want to do more things with it. But the biggest difference is the ability to deliver web content very quickly and easily, and the ability to host it and publish it very quickly. And that I see a big difference in, even just since a year ago tonight when I started this GEO 503 last summer. Even between then and now, I see that expanding rapidly, and that's not going to change. I think by next summer it'll be more continued integration of other devices. I think it will be an ongoing trend. So we'll switch gears a little bit and talk about web GIS also a little bit more specifically and what that means. And in the broadest definition, web GIS is the transfer or transmission of geospatial information from an origin somewhere to a user across the internet. So we're using this internet we've been talking about to deliver GIS or geographic content. In short, that's web GIS. So you have a couple general terms to this end. So basically, in the simplest version, we'll get into more nuances of this shortly, you have a server and a client. The server is the central location that contains the data and the WebGIS software. And as I said, it's more complicated than this, but in the simplest form, that's how you define these two things. The client is you. The client is the user requesting the information. So if I go to Google Maps, if you or ArcGIS Online, if you think about what's going on here, that's geolocation. So I click that button, the computer is connected to the UV network and knows exactly where we are. There's a server and a client right here. The server is hosted at ESRI. One of their ArcGIS Online servers has the address to this data. It has the ArcGIS Online actually uses ArcGIS server. There's an ArcGIS server program installed at ESRI, and we're using ESRI's cloud. That's where this map is coming from. So that's the server over there. And in today's world, it doesn't matter. I mean, that could be anywhere. I don't even know. I have no idea where that server is, whether it's in Redlands, California, where ESRI is headquartered, whether it's even in this country. But I don't care anymore. It makes no, as long as the content is delivered as fast, it could be across the world. It could be in Asia. I don't care because I'm getting the data quickly, which is fascinating to me. Used to be it'd have to be right down the hall. And so that's the server located somewhere. This is the client. I've got my laptop up here plugged in the projector, and I'm panning around. So in this example, the client is me on my laptop making requests to the data. So I say, my request is I'm going to move this map to the southwest. And these maps get so fast I can't even explain it. I have to explain it really fast. I move the map south, so a request goes to ESRI's cloud. Say, hey, this guy wants to move this map south. Something happens at the server and it sends a response back, and now I see the map move. So that's a quick demonstration of the client-server relationship. The request is sent via the internet using HTML, basically it's been built on, but the same founding blocks from the 1990s, just with more capability, using HTTP technology, which we'll talk about, to the server. So the request is sent to the server comes up with an answer and sends it back. And this is true whether the client is a desktop or a laptop like this, or if I'm doing the same thing on a mobile device. It might not even be a traditional. More and more, I think we'll see the client may not even be a traditional device like a tablet or an iPhone. I've seen cars with internet connections now, and there's a connection to a server. Say if your car has a recall, some of the Japanese automakers are really good at that. They have a computer in it where they can send a message out to a car if there's a recall notice on your car. And so there's a client. In that case, the client is your vehicle. And then your vehicle receives a message and they beep and let you do something for you and let you know that the car needs to be serviced. So as seen on the previous slide, transfer between clients and servers is accomplished through HTTP protocol, hyperlink text protocol. We'll talk about that. Through the hopefully everyone knows that's World Wide Web. So we'll talk about first, we're going to talk a little bit more about different types of clients. And first we'll talk about thick clients. A thick client is an application that enables some processing on the client side. Rather than sending the request to the server, having the server do all the work, even though data is coming from the internet, the client, the machine here, has some independent functionality through Bing or something like that. So often with that, we have the ability to, and a thicker client is Google Earth. You have the ability to continue in some form even without an internet connection. And one way Google Earth does that is by caching data locations that you frequently zoom to. if I zoom into Shanghai, Google is not, it's sending a request to Google server that, hey, please display this city. But it's also saving those images on my hard drive. So conceivably, if I lose an internet connection, these areas that I've already zoomed to will be also stored on my hard drive. You'll also notice Google does a lot of things locally, like measure tools and so on. So Google Earth is a good example of a thick client. I think I have a slide coming up, but just to mention now, the pros and cons of a thick client. Conceivably less internet traffic is required because more things are getting done right on your machine, your client. But the downside is now I need a better computer. I need more memory to be able to process, in theory, process things locally. So there's the con of a thick client. Nowadays that's less of an issue because our computers today are so powerful. So to build on that a little, we have another term you'll hear. It's two-tier architecture. In two-tier architecture, the server interfaces directly with a database. So you have a web server that the web server is exposed to the general public and it has web pages on it. But there's also a database in it. The database actually has the GIS, the GEO databases in it. In a two-tier architecture, the GIS web server is connected directly to the database, and then there's just a direct contact between the database and the GIS application. Between the database and the web server are seamless, and then they go directly to your client. Is a better way to put it. There may be some complications to that, especially for sites like Google or CNN, where conceivably millions of people could ask for data at the same time. And this is getting beyond my expertise, I can just introduce it. It's a whole other career. Sites with very high demand have what's called high availability configuration, where there's network we call load balancing. So they actually have 2 servers here, or for Google, maybe 2,000 servers, all with the same thing on it. And so when you make a request to Google, there's a machine that load balances. So in other words, it says you made a request right now. This one's not busy. I'm going to send your request to that server. Now this server is busy. The next person comes on. I'm going to send them to another server, and all these servers work together. That's called high availability configuration through network load balancing. In 3-tier architecture, again, I want to introduce some of these concepts. This isn't central to the rest of the course, kind of introduction of some of the things behind the scenes. There's further separation between the database server, the GIS application server, and the web server. So the biggest difference here is you have a separate server that has ArcGIS server on it and databases, and then you have the third thing in the tier is a separate web server that manages delivering that data to the public. The web server still communicates with you, the client, but it's more separated from the GIS application. Where in 2-tier, the web server has the GIS application on it. This is, like I said, just an introduction to this. You could take multiple courses, I'm sure, in the CS department about these type things. Any questions? No, we'll keep going. So I'll take a break. So some technical fundamentals, kind of list of definitions. Some of these we've already talked about, associated with WebGIS. HTTP, and I'm sure everyone has seen that. You type http// your website. If you didn't know, maybe you did, stands for Hypertext Transfer Protocol. That's the method by which communications occur on the internet. When you put HTTP in the website, you're telling it that that's the language that's the language the server can expect. You type HTTP www.cnn.com. When you send that request to CNN, the request says, okay, this is going to be a Hypertext Transfer Protocol request. You've also seen, I'm sure, HTTPS. An HTTPS site is secure. It's encrypted, in other words. That's why your banking and a lot of sites where sensitive information is stored are HTTPS. With HTTP, your data is sent across the internet in clear text. Someone can intercept your request and they can see exactly what you asked. So not the best if it's you're logging into your bank when you have your password and your account number in there. So HTTPS encrypts your data before sending it across the internet. So to host a website as HTTPS, a web server needs installation of a special certificate, and there's an agency that manages those certificates. So having an HTTPS site also is an added bonus of security and reliability. You know that site, there's an authority that manages what sites are HTTPS through this certificate.
It's a government agency?
I don't think so. I don't even. I think it's a non-profit. I don't even know. As you can see here, there's a lot of companies that will assist you in registering your company with a certificate. And you can even see Chrome and other websites will display. This is the website for this company, and it's an HTTPS. They display the green text in there with the lock, indicating that Chrome has inspected the HTTPS certificate and the certificate is valid. That's something I'm going to look into. So often any site that's e-commerce has an HTTPS certificate. We have some clients that have required this, and we go through one of these vendors. That's why I'm not sure where the vendor obviously then is registering your certificate somewhere. I don't think it's a part of the loosely organized governance that governs the internet. I'm sure the exact foundation. A URL, or Uniform Resource Locator, we talked about that, is the web address. A URL ensures that every web page in the world has a unique address, and that's done hierarchically. Places that open up to the internet have domains, we call. Like for example, the buffalo.edu domain is owned by .ub. But beneath that there can be many different websites. But the buffalo.edu part of the domain identifies the website as being associated with UB. And the language that's transferred via HTTP is HTML, Hypertext Markup Language. This is the main language for displaying web pages, so we'll spend some time in the class with a basic introduction to HTML. You could, conceivably, and perhaps CS does, you could have a whole course in HTML for all the things that you can do with it. Here are some server-side technologies. Computers that host website, and again, server is defined as a computer that hosts a website available on the internet. That may not always be available to the general public. There's plenty of sites available only on an internal network. There's sites at UB that are only available to UB students, and so on. So the internet may not always mean everybody in the world. Many sites are on the internet but restricted, either via password or actually restricted to a certain IP address where it's only available in one organization. So in the simplest, here's the internet in 3 bullets. The server receives an HTTP request from a client. Someone types HTTP www.cn.com, hits enter. That request goes to the web server. It does something with the web server. So in this case, through CNN.com, there's a thing called a DNS lookup. And I'm getting more involved than I need to. The DNS lookup is, oh, CNN.com, that's this server in Atlanta. Sends the request. The DNS server tells the client which server on the internet has the information you're looking for. CNN.com Atlanta, Buffalo.edu, that server's right here. That server then processes a response. If you type CNN.com, the response is, this person wants to see the main CNN page. It comes back with a response in HTML, and then that's what you see in your browser. So the internet in 10 seconds. In addition to specialized GIS software, the servers have web application software on them that manages handling all these requests. Very often nowadays there is the application is called Microsoft IIS, or Internet Information Services. Other similar programs that do the same thing are Apache Web Server or Tomcat. Many organizations use Microsoft IIS. So when, say, that server in Atlanta that runs CNN, when it gets the requests, this person wants to see the CNN webpage, the software that handles all these requests processes them and sends the result back is this Microsoft IIS. And again, these are all background introductory things to kind of give you the big picture. We wouldn't have time in 5 weeks ever to go over all these things. This is like a whole career of information, but I want to provide the background. Programming technologies, and again, there's a lot of new that's one of the hardest things nowadays. There's so many even programming environments out there for you to learn or be stressed that you don't know. Pick one. C# is a good one, JavaScript. So some programming technologies are Java. Java applications run on the server side. ASP.NET, the Microsoft .NET framework, is often used. That's what Visual Studio is set up to run in. I'm not sure how much we covered this specifically. We may not have talked about it much, but when you developed tools in GEO 555, as add-ins or the Windows application, you were developing in the Microsoft .NET framework. And you did that with Visual Studio 2010, which is C# or Visual Basic. We use C# in that course. We will use Visual Studio in this course too, 2010, which is on these servers. We'll focus more, I don't know if we do much with C# here, maybe none. We'll focus on HTML and JavaScript in this course instead. So those are server-side technologies. Web application technologies. Oh, I didn't advance. Now the other side of the game is client side. So on the client side, some things that we have on our client that help us happen is the web browser. And everyone knows a web browser. It's a local application. I mean, when you install Chrome on your machine, Chrome is local, installed on this machine. Chrome retrieves a data from a website given the URL and then renders the content. And like I showed in the beginning, I type CNN.com. Chrome actually received a bunch of text. It didn't receive these pictures. When I made the request to the server in Atlanta, I got this. That's not very pleasing to look at. But Chrome understands HTML, so Chrome can take that and convert it to this. So that's what makes it a web browser. Some programming technologies involved with Chrome or web browsers. JavaScript, that we'll use so much in this course, was first invented, that was used in this Netscape that I talked about in 1995. And it's amazing to me, it makes me happy. I learned this that long ago. There's so many things that have completely come and gone. I mean, to the point where I mention them and you look at me like you don't even know what I'm talking about. So many technologies have come and vanished. It's amazing to me that JavaScript is making a comeback after so many things that have come and gone in the last 20 years. It's widely used today, maybe even more used today. It's because it has such a wide dissemination, makes it an ideal platform. It's lightweight, and we'll talk about that. Things like Java even, or Java and JavaScript are two completely different things. Java or Flash or Silverlight are very intensive. You get more things like this. I mean, let's face it, these are cool. They don't have the power that a computer does. So you really need to program lightweight. Your program needs to have a small footprint because these things aren't super memory intensive. I'm sure they will be, but they're not yet. So that's led to JavaScript's return. And it's simple. I think especially those that know complicated programming languages and maybe haven't done much with JavaScript, you'll be pleasantly surprised. So it really is widely used today, whereas so many things in the same 20-year period are gone forever. It's sad how many things I've learned over the years that are now useless. You'll see what I mean. Probably worse. Technology is doing this, so you'll probably encounter that even worse. Yeah. AJAX stands for asynchronous JavaScript. That's a little more recent. I guess that's still 10 years old. That was a big development. Before this, when you made the web was as simple as I presented it. You made a request, it goes to the server, comes back. So, let me see, which site would I... So the whole site would draw. Everything's a new request. With AJAX, asynchronous JavaScript, you can only send a request that affects only part of the page. And this cut down on the amount of internet traffic to let us build faster, easier web pages. Before AJAX, every little request that I did, it's like starting over with your page. If you notice, if I change, right now this is showing the weather radar, which doesn't look good. But notice when I change radar type, there's reflectivity that shows a different. This is cool. It shows the accumulation of total rainfall per hour, so you can kind of see total rain building up. Looks like there's more rain has happened east of us. But I'm going to do that again. Notice the whole page doesn't redraw. It's redrawing the radar, but the banner, all their logos, I think. Stay there. Notice it didn't redraw the whole page. And as someone that was a web programmer before this, that's a big deal. Before, you would start from scratch. And every time you click, maybe you might even remember that with all the older web pages. Every time you click something, it was basically re-requesting the entire page. So AJAX, starting around 2005, allowed us to retrieve data. And to explain it, this is an even better way to explain it. The way that it does that is you can retrieve data from the server in the background. That's how they're doing that, without redrawing everything. So when I click to see a different type of radar on that page, I'm making that request, but I'm not getting an entire web page back. I'm just getting partial content, basically just the new radar map. So I can insert that partial content into my web page without redrawing it from scratch. That was a big deal, and remains a big deal. And then finally, I don't mean to put these I wouldn't have said this even 2 years ago, but I wouldn't invest a lot of time in these. These are things that have come and gone and completely left me behind. I never even learned that, and now it's gone. But Adobe, going back even to the late 90s, Adobe Flash was big. Maybe it still is. I shouldn't put them to death yet. But it's very client intensive. Adobe Flash does not work on mobile devices. Neither Microsoft Silverlight excuse me, was to be Microsoft's answer to Adobe Flash. And responding to that media, Sarai came up with APIs, programming interfaces for RGS Server that used Adobe Flash. They called it Adobe Flex, and one that used Microsoft Silverlight. A lot of those sites are still in use. We have a lot of sites in use with these still. They're not dead yet, but if you're new to this, I really wouldn't, 5 years from now, this may be on the history slide at the beginning of the lecture. I wouldn't invest a whole lot of time unless you specifically need to know them for something. And this was Silverlight, especially something I always said I would learn, and it's been so long now I don't have to learn it. They're generally designed for desktops that neither runs on mobile devices because you can do cool things. I'm not meaning to put them down. They're client side, so they require a beefier computer to run it. Because a lot of what happens with Silverlight and Flex happens on the client. A whole delivery of data will come down through the internet to the client and run locally. So there's a reason, and that's why I focused the class on the JavaScript API exclusively. Because I really think that I'm right about that. JavaScript API is getting much more important. These are becoming less prominent. I want to talk about stuff that I think will benefit you the most when you leave here. Any questions? But that's not to say it's dead. I mean, it's a struggle in private industry because you need funding, and there's sites that I'd like to convert to JavaScript, but if there isn't money right now to pay for it, and the site's working, it's like, well, why mess with something that's working? But I would love to be doing more of that, and I'm sure we will over the next couple of years. But we have plenty of sites that work in Silverlight that work just fine. However, this is a change. I should put that on the slide. This just happened a month ago. It was like everyone ganged up on me. One morning I started getting calls from multiple project managers. Hey, the sites aren't working. And I came to discover that Google Chrome has removed support for Silverlight as of late April. So now, on all our Silverlight maps, I have to tell our project manager to alert users they can only use Firefox and IE. Chrome does not support Silverlight anymore, and that was not announced. It was just something after that horrible morning where the phone wouldn't stop ringing, I had to do some research to determine that, and I wasn't too happy. But there's not a whole lot I can do about it. That's the beginning of the end for these, in my opinion. Any questions? XML is a more generic, is extensible markup language, is like HTML. XML is more like the parent. HTML is a specific type of XML. Extensible markup language allows you to define your own attributes and store data in clear text. XML is something that's widely used outside of GIS, just like HTML. Very little of what I've talked about so far is GIS specific. So here's an example of someone defining features using XML. So a pro is XML is very easy to read. You can look at this and see exactly what this XML file is about. The abstract, US this is an XML file of metadata put out by ESRI for a GIS layer of telephone area codes within this country, where we can see a lot of information. So when I say tags, and you'll see this exact same format with HTML, we define an attribute called origin. This would be the origin of this data set. So the attribute starts here and ends here with /origin. And so in between those two tags, we see the origin is TomTom North America. That's the company that developed this area of, shows the boundary of US area codes. Pub date is another XML attribute. It was like 2012 is when that was published. The data has a title, US telephone area code boundaries. So the title starts here with that tag. Here's the content. You know the title ended because you see the /title. That, in a nutshell, is XML. So you can see here the pro of XML makes it easier to read. You can look at this very easily. It's not compiled. The con to it is it can lead to giant file sizes. You can produce some gigantic file sizes, and if you're delivering them over the internet, where internet speed is an issue, that can be a problem. Those of you, which is many of you that have taken 555 either just last spring or a year ago, do you remember the config add-in file that was developed with the add-ins? That was an XML file. That was a very different XML file. It was an XML file that Visual Studio used to define the add-in you created. Very different than this. The purpose of this is metadata, but that config add-in X file was an XML formatted file. You just didn't know it, or maybe I did mention it. Another more lightweight data exchange format for transferring data is JavaScript object notation. You can use or JSON. You'll often hear programmers call this JSON. It's JavaScript based, and it lets you define objects using this format that you see here. We will learn JSON in this course a little while forward. So here I'm creating an object called pop by race, and I'm defining its attributes inside the curly brackets. So this object defines a county as Los Angeles. So inside the curly brackets we have a string that represents a field. Then there's a colon, and again we'll get into this specific format later in the course. But we have attribute colon value. This is JSON. It leads to smaller file sizes in XML, and we can use JavaScript to parse this very easily, and we will maybe a week or two from now. So it's information about the demographics of Los Angeles County, California, how many people live in the county that are white, black, Asian, and so on. This, what I should have done is shown this same information in XML, and you'd have to imagine it. Just looking at the format of XML versus JSON, you might imagine how JSON presents the same data in less characters. So as I wrote up here, JSON provides smaller file sizes, and that's always an advantage if you're transmitting data over the internet. It's a lot faster than when I was your age. I mean, there's no question, but the internet speed is still a bottleneck. It's still your biggest limitation. I mean, you've got very fast, well, some days, you've got fast machines here in theory. You've got a real fast server somewhere that does data. Even in 2015, the main bottleneck is the internet. It's getting better year by year, but that's still, so anything you can do to reduce the amount of traffic back and forth in those requests, you can help your website become more successful. Any questions? Sorry. So a couple more slides. We'll take a break. We'll come back and start talking about HTML. It's 8 o'clock now, but we won't go all the way till 9:40. So I said WebGIS is the extension of a web application to include GIS capabilities. And this is somewhat of a review. The client sends requests through the server using HTTP. We kind of already talked about this. but this slide shows more specifically an example of the web application being our GIS server. So this introduces some other things we didn't talk about, is how did the web application come to be? Someone, and that's impossible to read, I apologize, ArcGIS Desktop, all of you know that. We use ArcGIS Desktop to publish a map, to gather the data, shape files, geodatabases, you all know how to do that. And so the same thing that you used in your labs in previous courses in 555, the same architecture is used to publish an online map. So we load data into an ArcMap MXD. We publish that, we symbolize layers like we did in the spring, publish that. But instead of just saving an MXD and showing me your lab, the extra step is to say, okay, now that I've made this map, I'm publishing it to the internet. So we said that that's the thing we can't really do at UV too easily, but I'll show you a demo of doing it through my company's service. And so once that data is on the internet, it can be served to the general public. There are tools like ArcGIS Server Manager, our catalog help us manage those sites. And then through the internet, those sites become available to clients such as web browsers, tablets, and so on. The types of clients that use GIS, just to review some of this. Web browsers. Originally, that was the only type. Previously, when we talked about WebGIS, it was web browsers was the client. Up until recently, that was the client. Still very common, but there's a number of other different desktop applications like Google Earth. ArcGIS Online base maps. You can now add ArcGIS Online base maps right to ArcMap. So that's kind of a hybrid, and you see that more. When you're using ArcMap, you're using a local desktop client. But if you add a base map like aerial imagery from Esri, you're using a combination of shape files right from your C drive or from the geography drive, along with data from ESRI, say the web map. There's a variety of potential bottlenecks that challenge a successful GIS system. And people have high expectations nowadays. This is amazing. I've read a couple studies that say if someone opens up a website, after 3 seconds they're impatient and they notice that they have to wait. People are that demanding that you better have something there within 3 seconds. It's kind of sad. But there's a lot of bottlenecks that can cause users to have to wait. And this lists them there. To me, number 3 is the big thing, the internet connection speed. But this lists 5 potential bottlenecks. Pressure to support the data. Your data comes from a GEO database. So if suddenly 100,000 people ask for a feature class, your GEO database server may not be equipped to handle that many users. Even if the rest of this is fast, you still have to you still have to get the data. Google, I'm sure, has a web mapping server, but Google's also storing their data somewhere, and they have to retrieve the GIS data layers to build the map. So that's a bottleneck potentially. But even the GIS server and web server is the next bottleneck. Say you've retrieved the data quickly from the database, but rendering it into a map could be your bottleneck. These servers may not be able to do that quickly. This to me is offering a huge effort, especially pressure to support a frequent and large data transfer. Especially with these, I get calls from colleagues all the time. And this is slow. It's like, well, you're out in the field. You're asking for GIS data over a cellular network. It's not as fast. Like, it's not as fast as when I was in my office. Like, well, yeah, because you're not in the office. And data out in the field where you might not even have an LTE signal, you might have a Verizon 3G signal, it's not going to happen as fast. And a lot of people, I'll get to number 5 in a minute, a lot of people expect things to be just, no matter where they are, as fast. So when you're using these more and more, that internet can be a bottleneck. Because now more and more people are getting their GIS data across the cellular network. The cellular network has made a massive advancements in the last 5 years. I mean, sometimes the LTE signal on this phone is faster at home than my Roadrunner cable modem. So that's a new thing, but it's not faster than the very high quality internet connection at work or UB. It was slow today, but UB is like the fastest anywhere. I think there's a T1 hub right below this university. So UB has a very fast internet connection in my experience. So people used to UB may go out in the field with one of these and be disappointed because you're not going to get the same connection. Limited capabilities of the client. Your desktop software may be slow. We found that in the spring. The software, some of the labs that you wrote, through no fault of what you wrote, just took a long time to draw. That's a limitation of the client. That was a limitation of ArcMap. That can be a bottleneck. And sometimes I have to explain to people at my company, it's a difficult explanation when I have to tell them, I don't have a solution for you. It's just slow. They don't like to hear that, but sometimes that's my answer. It's like, I can't do anything more to make this faster. And then that relates, we deal with this a lot, expectations of non-professional GIS users. You'll unfortunately have to deal with that. People expecting it to do something that you can't make it to do. And people don't like to hear no sometimes. Sometimes the answer, and I like to think the answer is always yes, but in reality the answer is not always yes. I have to tell people, no, I can't do that. Or a variant of that is, no, I can't do that for the amount of money that you want to pay us to do that, which is even trickier. So the web GIS faces a number of challenges. We talked about thin and thick clients a bit. I should have put this slide back a little earlier. But with thick clients, a lot of work is done on the client side, on the local machine. With a thin client, most work is performed on the server. So clients that do not require significant processing other than displaying results. Google Maps is a thin client. Everything happens at Google, it just sends a map back. You don't really need a high-functioning computer to run Google Maps. This works well in a situation where you have users with low-end computers. With thick client, the user also does not need to install any software. That's something that hurt Adobe Flash and Microsoft Silverlight, is that it requires plugins for the thick client technology. And some, especially like, for instance, in the US government, there's a lot of limitations for security reasons on what users can do. And in the worst case, I've been involved for a federal agency. A person at the agency asked us to build a Microsoft Silverlight site, not realizing that his colleagues couldn't use Silverlight. He could. That was an uncomfortable day. When we deployed it and they said, oh, none of us can see this. Well, they didn't have a permission, so we'd spent like a couple months building these Silverlight-based tools. He could see them just fine, but then when he showed his coworkers, it just came up with the broken link. That was an awkward day. So, that's a downside to thick clients, is people often can't use the thick client functionality. That's where thin clients work well. The con to thin clients is that puts tremendous pressure on the server, because now everything's happening at the server. But someone like Google can afford that. I can't imagine how many servers they have in Cupertino. I think they're Cupertino. And it also tends to limit user interaction, because everything is going to the server for processing. With a thick client, more work's done on the client side. The application is initialized on the server but relies on a local web plugin like Silverlight, Flash, or Java even. Very faster interaction because more mapping can be done locally. Thick clients can take care of some requests without having to return to the server. So it also can reduce server traffic. The server doesn't have to be as prominent, but the client now has to be more powerful. And as I said a moment ago, with the con of thick clients, local installations can be difficult, especially in situations where users may not have permissions. This reduces server load, but it doesn't necessarily reduce network load, because you still have that initial shift of data. Specific types of map services is another. It's important to mention. We all think of web services as serving up a map. mean, I think that way because that was traditionally what they are. And I think all the examples that I gave you were map services. You know, where you're asking for specific layers. Google Maps is a map service, or so is I mean, this is a map service. I've said I want a map of Bangkok. I want it at that scale level. Maybe I want to see current traffic. Traffic's fine. It's probably the middle of the night there. I want to see typical traffic. So on. This is a map service. The end result of this service behind Google Maps is a map. And while that's most commonly what it's used for, that's not always. You're doing things which I just did, like choosing what layers are on, choosing the map extent. There's query and identify. I didn't do that, but I could have. I can click on things on the map and get information, and a map comes back with a GIF. Some additional types of services are feature editing services. We're doing more of this online, where Google doesn't allow it, but we've set up applications where users can remotely edit GIS layers. We had a major project this summer at the site of a potential new natural gas pipeline in Pennsylvania. We had people all week mapping wetlands in the field. And what they did is, back in the day, then they would look at what they've mapped on their GPS units. They'd send us the data, we'd have to print out paper maps, have them sent to the hotel. They would write on a crayon, this is wrong, send it back. Now we have an application where a feature editing service where on Saturdays, these unfortunate biologists are there for a while. We have people at this hotel in Pennsylvania for 6 months. There's not a whole lot to do on the weekend there, so they would spend their Saturdays. It sounds horrible, but they like to build up their comp time. They could come home and have 4 months off after something like that. But they would spend their Saturdays going through what they had captured and reviewing it, and rather than bothering us, just fixing it themselves using a feature editing service. GPS is not foolproof, and sometimes most of what they're doing is mapping wetlands, so they would map the outer boundary of a wetland. They might, on Saturday, look at it on the map and say, no, that's wrong, that's not what I meant. And now they have the ability through a feature editing service to just modify it themselves without having to involve us. So obviously that leads to the final wetland being available to the client quicker. It also reduces cost because you're not shifting maps back and forth with them. Search services or geocoding, I'll mention those together. Geocoding service might return in geographic coordinates. You put in 105 Wilkinson, Buffalo, New York, and the result is a latitude and longitude. It's not necessarily a map. That's a geocoding service. It's taking a street address and converting it into geographic coordinates. I won't show that. We'll actually do something like that in the course. Image services, Google does that too, provides online access to a huge amount of imagery data. Geometry service, this is something newer. I could use an internet service to do things like buffers, intersects, and get a result back. We will do that a little bit in the course too, where the result isn't a map, but it's a new shape. I'll send you using JSON or XML, the outline of Ohio, send it to a geometry service to say buffer it, or intersect it with something else. So it's 8:20. Why don't we take a short break? These nights are long.